I have made you host. Okay. और
Okay.
लाइव है अभी, ठीक है. Bye.
Okay, thank you. So hello everyone. Welcome back again in my sessions regarding the designs of electronics and project. So today's session is also going to be interesting like earlier. So this session is about how you can design your own FM radio. And I have designed the two versions of FM radio, and those are the smallest one that can fit in your smartwatch. It's a smartwatch size, and other that can be fit in your earphone as well. So, but in this session, we are covering the first version, and in consecutive session, next session of me, you will get to know how you can design the FM radio that can fit inside the earphone as well. Okay, so this is going to be pretty amazing design, and I hope you will enjoy. So let me first show you how our device is going to look like. Okay, so here if you can see, let me know in the comments. Okay, so this is the video of the FM radio. Here it is connected to my PC, my laptop. Just for the powering, I am powering it using the USB. If you don't want to power it using USB, then you can power it using the battery, 3.3 point battery as well. This is, as you can see, this is very small. It's this size, and I have a touch display over it, over which I have the play button, and using this button I can change the the frequency of FM radio for different channels like Radio Mirchi or FM Dhamaka, whatever there are different FM radio stations are in your locality. You can change the frequency using this and listen to that FM radio. And this very small this size. Okay, so as we are going to make and there is another version that I have made is this one. You can see this one. This is another version that I have made. This is another version. It's that FM radio that can fit inside your earphone. Okay, so here is the another peak of that. It will fit you inside like this, and whole FM radio can be fit in your earphone like this. Okay, so this is another version. We are not talking about this version. This is going. I'm going to tell you about this version in later. Okay, in next session we are going to talk about this one right now. That you can see this one. Okay, so as we're going to make the our few features and mottos that we have, that our FM radio can have the UI and touch screen using which you can operate the FM radio, scan the channel, change the channel, play and pause, raise the volume, or whatever the other thing. Then our FM radio should be very small size, so it's portable, and it can fit inside your watch as well. Okay, so it need to be 3 centimeter size, a smaller size. And for that, we also need a smaller chip for the FM radio and a smaller MCU for the FM radio. Okay. So for that, we can if we go for the specification to choose the components for designing this kind of FM radio. So here for the MCU programming and processing and whole things, I have choose the Indus board coin. This is the Indus board coin. It's a 3 centimeter size only. Its size is only 3 centimeter. Okay. This is the Indus bud point, size only 3 centimeters. Okay. So we are going to use this microcontroller for designing the FM radio, and for the FM radio, for the receiving of FM radio, we are going to use there are lots of different kind of FM radio chips out there, and you can also create your own FM radio receiver circuit as well. Okay. So here I am going to use the chip because it need to be small. So the chip that we are going to use is this one, RDA 5807M. So this is the FM radio chip that we are going to use. You can see here in the camera. So here you can see in the camera, this is the FM radio chip. You can see. Here you can see the camera. This is the FM radio chip. Okay. And it's very small size, you can see. If I want to compare it with the size, then you can see this is my smallest fingertip. Okay, this is my smallest fingertip. It's this size. Okay, it's this size. So let me compare it with another one thing. So this is the USB chip. This is the USB plug, and it's of this size, around just USB plug tip. So it's very small size FM chip. Okay. So let me show you one more pic of comparing this thing with the pencil Okay. So this is the chip that we are going to use here. This is our chip, FM radio chip. So using this chip, we can control the volumes. We can control many functions of FM radio. We can scan the FM station. We can change the different frequency. It can act as a complete FM radio circuit. Okay. So this chip will help you in that. So if I'm going to compare the size, then you can see the tip of this pencil. Yeah, it's around the tip of this pencil, and this is the earpod where we have placed the FM chip for the FM radio. That's the another version. So you can see the comparison of the size of the FM chip. So we are going to use this chip. This size only just around 1 centimeter or below the 1 centimeter. Okay. And so the chip name is RDA5807M. Okay, this is a chip name. You can comment me out for more details if you need more details, and if I am and if you are able to understand me or not. Okay, you can comment out in the very you are watching. Okay, yeah. So this chip name is this. So let's talk about the data sheet of this chip. So this is the chip that we are using, and this is the data sheet of the chip. Okay, so here is the chip. So here is the chip. Here is the chip, and this chip data sheet is here. Okay. Here is the chip data sheet. Okay. So in the data sheet, you can see we got these pinouts that there are total number of 10 pins out there. 5 left side, 5 right sides. It's okay. It's SMD SMD chip. Okay. And you got 2 pins here for VDD and GND. These for the powering, the power line chips. Okay, these pins for the powering, this GND and this VDD. Okay, and this GND and these chips, you got this ground pin is for the output, the audio output for the FM radio. If you want to listen in the US microphone, earphone, then you can use these stereo, and this is a stereo. This is another good part of this, that is a stereo FM radio receiver. So it give you stereo audio. Okay, it can left and right, 2 audios are there. It can give you 3D sound as well. Okay. So if you are going to use the earphone, you can directly connect the earphones, left earphone, right earphone to the left out and right out, and the ground pins on that of earphone plugs. Okay. If you are going to use with the speakers or any other thing, then you can make a TTRS, connected. This one is a TTRS connector, and then attach your speaker or whatever speaker you are going to use. Yeah. This one is the TRRS plug. Okay. This one. This is called tip to ring plug. TRRS. Tip to ring plug. Okay, so you can use this plug for the connecting to the. You can solder this plug to these pins. To these pins. Yeah, to these pins. To these pins. Okay, for connecting it with other speakers. Okay. Then we got a CK and SDI. This is the main pin that connect to the microcontroller. Okay, so SCK, this work on I2C. Using the pin name, you will be able to get to know that this work on I2C. That is the inter-integrated circuit I2C peripheral. So that is the SCL SDL pins. Okay, so you can give the signal. You can give the command to this whole FM radio chip to change the frequency, to rise the volume, to lower the volume, to scan the FM radio station, to change the FM radio station, to play or pause, whatever the different function, you can send the command using this I2C pins. Okay. And then we have this RCLK clock. This is the external clock line pin. We are not going to use it. So our pin that we are going to use is this one for the audio. These 2 are for the power line, and these 2 for the command line. Okay, for sending the command using R2C pin. Okay, so this is a data sheet of the FM radio. So here you can see this FM radio can communicate with our MCU, and that L and R, the left and right, is the DAC pin that is connect to the speaker. Okay, and then we have the antenna, integrated antenna, and integrated crystal oscillator. You can see the crystal oscillator in the chip here. If you see the video here, Yeah, here you can see this is the crystal oscillator integrated inside the module itself. Okay, this is the crystal oscillator inside the chip. Okay. So okay, so this SDA and SCLE pin connect with my FM radio back of this Indus Board point. So if you check you can connect this SCL and SDA to the any pin of the Indus Board point. But if I check the data sheet to use the default I2C pin of Indus Board point, then I can check. So here in the data sheet of Indus Board point, you can see the I2C pin each 8 and 9, 8 is SDA and SCL is 9. So we are going to use SDA and SCL pin of the Indus Board coin and connect these pins of this module. Connect this pin of this module. Connect this pin of this module to that 8 and 9 pin. Okay, and this whole board you can on this data sheet you can see the whole thing is can be work in the as low as voltage of 2.7 to 3.3 volt, and this is the same range that our Indus Board coin also work in the same voltage range. So we can power the whole chip using the Indus Board itself. Okay, Indus Board GND and VCC pin, these pins, this GND and 3 volt pin, we can power the this chip as well. Okay, so this is our whole connection of the design. This is circuit design that that we are going to do. Okay. Okay, this is the don't see this part for now. This LCD part we will take it later. Okay, so for now let's see this part. Okay, so here how we connected. We connect the ground pin to the Indus Board ground pin, and then the VCC pin to the Indus Board VCC pin for the power line. Okay, and then SCK pin to the so clock pin to the 9 and SDA pin to the 8 according to the SDA and SCL pin of the, and these two pin we are not going to use here. Okay. Yeah, this is for the connection with the our FM radio and the MCU. Now that part is ready. Okay. So now let's for the UI for controlling, you can either use the button with the OLED display to view the FM radio channel, and then you can use the button for that. But here I'm going to make it little bit advanced and let it make more little bit beautiful. So I have choose the round display. That display is GC9A01 round display. You can use any touch display if you want to make it more good. So I am using this one. This displays GC901 with the touch display, and it has the touch capacitive touch IC for the touch sensing is CTS 816. Okay, so we are going to use this display, and this displays work on SPI. So you can connect any of these pins, leftover pins on the board for the SPI, and simply configure that thing. Okay. So here I've connected the MOSI pin and the SCK pin and CS pin, DS pin to the 6, 7, 8, 9 for this LCD display. And then 8, 9 is the I2C pin. So I have this LCD touch display also display touch IC work on the I2C. So we have connected the same SDA and SCL pin to the same 8 and 9 pin here. Okay. And then there we have connected here a speaker. You can also use the TTRS pin. Okay, so this is all about the connection we have done. Then you can, after connecting thing, you can solder the whole things behind the display like this. Okay, like this. So you can solder the whole thing like this. So everything fit behind the display and the MCU that we are going to use in just a small 3 centimeter size. So it's the smallest FM radio that we are going to make it. Okay. So now after that, our hardware side design is done. Okay. Now let's go for the coding side. So this FM radio, you can drive this FM radio using the library. Here we have the library for that. that library is the Radeon. You can download this Radeon library. You will get this radio library. You can search it, or you can get this radio library when you bought it the chip or module from the market. The distributor will provide you, or you can download it from here. You can save this link. This is the link of the for the library we are going to use here. This is the link. Okay. So you can download the library and add it into the Arduino IDE. After downloading the library and adding to Arduino, you can go for the examples. And here is the simple example for the radio, how you can use that radio. So let's open the example code and let's understand what are the keywords using which we can control this radio. So here we have the keywords for increasing and decreasing the volume or setting the volume of our radio. Each a radio dot set volume plus B or radio dot set volume plus minus radio dot set volume, get volume to get the radio volume. So using these keywords, we can able to set and control the volume level of our radio, FM radio. Okay. And using this keyword, radio set mute or radio set mono or radio set bass boost, we can able to control the sound quality like mono, stereo, or adding the bass to the sound, or getting the FM radio mute, play, or pause. Okay, using these commands. Okay. So now let's go for the more thing for skipping up, seek down. Okay. The radio channels, you can use these commands. Okay. For setting the frequency, radio dot set frequency, you can set the frequency for the radio channel that you want to get. For getting the frequency, you can get for scanning the frequency. So all these are different keywords using which we can use these keywords from the example code in our creating our FM radio. Okay. So now let's go for our code. Okay. So here is our code. So here is our code. So for displaying and creating UI, we are going to use the TFT ESPI library. Okay, so here I have installed the TFT ESPI library and including the code. And for the touch display, you can use any other display as well. It's not restricted to that. You can use any other display that you already have. You can use the OLED display, you can use the TFT display, you can use the LCD display, whatever display you have. Here I want to make it a small circular watch size, so I am using this display. Okay, it's not a matter. Okay. And then we have included the library that we have downloaded earlier, that RDF580 FM radio library. And then we have set the TFT display and touch display pins. Okay. And then we have to set the default frequency at which when you will start the radio. So like here, I have set the default frequency 87.75. So whenever I plug in, it will my radio will start streaming the audio from data station 87.75. You can see 87.75. Here our radio is start streaming the audio FM radio or that frequency. So you can set the default frequency here. Here, whatever station you want to listen more, you can set it that. Okay. And then we have create few UI buttons. Okay, these are the UI buttons using which I can control the FM radio, like changing the channel, changing the station, playing, pausing. These are the tip. You can add few more buttons for like for other functions like bass, which like bass create like bass control or mono stereo control, seek, play, pause, and other different functions. Scanning the station, storing the station, saving the station, renaming the station, whatever other function you can also create. But here I am going to make a very basic and simple one. You can add more function and add few more function to the UI, and your radio device is going to design. Okay. And here is the IO2. It's the address of the radio display that is default we get from the code that we have downloaded. The library that we have downloaded. Okay. And after that, we are using the UI, created the UI. Here we will check the FM radio, and FM radio is detecting or not. Then it will set the frequency band and all those things. Okay, here we have created the UI, these buttons, and it will check those play, pause buttons, and all those buttons are not touched or not. If those buttons are touched, then we have set the different function for each of these buttons, like play, pause function, next button function. When next button is touched, then it will change the, change the frequency, and all those previous instructions change to the previous station. So whatever the next channel, here is a function. So different function we have created. For if you want to add more function, you can do. After creating this code, you will get the whole code on the website electronicsforyou.com in upcoming week. Okay, download the whole code. And after creating this code, we will upload this code. Okay, after uploading this code, our our FM radio is ready. So I can attach the speaker to that, to these pins to listen to the FM radio. The sound is very small, so you can't, you can only listen, work on the earphone right now. If you want to, if you want to listen on the bigger speakers, then you can use this TTRS module. Okay, where is the thing? So here in this video, you can see I can touch these two pins and change the frequency. Okay. See, when I touch these pins, I can change the frequency. Play and pause. Okay. See, the frequency is changing every time I touch. I can change to the next frequency, 51. So you can change the frequency of station. Okay, of this FM radio. I have taken out the chip from this FM radio that we have right now, so that I can't show you, because it will not work without this chip. So I have taken out the chip so that I can show this chip to you. That's what this is. If I connect this to this board, then it will start working. Okay. And if you want to hear the audio output to the speaker and all those things, then you can use it. And I have connected this display. As you can see here, here is my display pins. Okay, I have connected display to the SPI of this board. You can define these pins in your code. You can use any of these pins on the Indus board. Okay, and I have soldered it. Or you can design your own PC around this FPC. There is a FPC connector behind this Indus board point. Okay, so you can design your own PCB like this for the FM radio. So whole radio will connect using this FPC connector, and here is the chip, here is the speaker. So whole FM radio, PCB get directly connected to Indus board one and start working like that. Okay, so you can design your own custom PCB using the FPC ecosystem of the Indus board one, and you can design your own smallest FM radio. Okay, so in next session we will test. We will give you the live demo of this one and also this one, and we will test the smallest FM radio that is fit inside your earphone. Okay, this one, FM radio inside your earphone. This one that fits inside your earphone. Okay. So if you have any more question regarding this project or regarding the any Indus board project as well, you can comment me right now wherever you are watching, and then I will take those questions. Okay. Or you can also use the WhatsApp group. If you are from the Indus board Coin WhatsApp group, then you can also use the WhatsApp group. I will take the question from there as well. Okay. So as you can see here, this is the whole circuit diagram. You can take the screenshot of the circuit diagram, and this whole thing is connected. This whole thing is connected like this. Okay, so this is the circuit diagram of the whole thing. So if you want to ask any question, then you can ask me out. Okay, in the group as well, or from wherever you are watching. Okay. So I am waiting for the few more seconds. So if you have any question, you can ask me right now regarding any doubts regarding the Indus board coin we are using, or you have, or any project, or regarding this project as well. You can also ask the question in the group as well, Indus board group as well. I can take the question from there as well, or you can also comment it from where you are watching live. Okay. Yeah, we got one question. Is there any Indus board coin simulator where we can run the code and check the various output without having real hardware? Currently, there is no simulator right now, but yeah, you can take the help of the AI and you can test out the circuit a little bit on the circuit, circuit designer. This one. Okay, here, circuit designer. This one here. Here you will get the Indus board point, and they also have the simulator, but it's not working correctly for the Indus board coin. Yeah, maybe in the future it can work. Okay, so you can use this one for now for taking the help of the AI whether your circuit will able to work or not, testing your circuit. So you can search the component here, Indus board coin. 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 Yeah. In that, yeah, here. So you can use this circuit designer and import the Indus board coin board in the circuit designer, and you can try the AI thing here for that. Okay, for testing out the circuit as well, but it is not working at like full simulator, but a little bit. Okay, not full-fledged simulator for that. Okay. Generally, most of the board do not have full-fledged simulator using which you can test out the circuit. Most of the board do not have. It's better if you have the hardware and try it by yourself. If you face any kind of problem, they can use the AI from that platform, or you can use the chat GPT as well for diagnosing the circuit. You can also use our community to get help from the experts as well, or from me as well. Okay. So any more question? So hope all of you have learned a lot of things from this session, and if, you can also comment out more question if you have later as well. Where from wherever you are watching, I will take the question and give the answer to all of you. Okay, thank you everyone. And this whole code and project will be published on Electronics, but you can download from there. Okay. हेलो सर, लाइव एंड हो गया?